Hello everyone. In this video we'll be talking about reaction mechanism. What is reaction mechanism? Reaction mechanism, it gives a step-by-step information about a chemical reaction. How does a chemical reaction actually occur? The information about that is given by reaction mechanism. So the reaction mechanism is what does a reaction mechanism do? It gives us step-by-step information about a chemical reaction. Under this heading, first we'll be studying about the first thing what we'll study is bond fission. Bond fission. Now what does this bond fission means? Bond fission is nothing but the cleavage of bond. So cleavage or breaking of the bond. If this is a bond, the cleavage of the bond or breaking of the bond. What is bond fission? Breaking of the bond is bond fission. Now this bond fission is of two types. Bond fission is of two types. The first one being homolytic cleavage. Homolytic cleavage. What does this homolytic cleavage means? Homolytic cleavage means when a bond, a sigma bond always has two electrons with it. If the bond is cleaved by dividing the two electrons or giving one electron to one atom and another to other atom or equal share of the electrons, it will lead us to a free radical. So homolytic cleavage always gives us two free radicals. Now this homolytic cleavage is due to, it can be due to H nu, UV light, this is light, UV light, free radical action. So we'll write here H nu, UV rays, free radical and peroxide. Due to this, homolytic cleavage will occur and it will give us a free radical. The second type of cleavage being heterolytic cleavage. Heterolytic cleavage. In this type of cleavage, the electrons are from a bond are completely lost or completely gained by the atom. So this, if it is cleaved heterolytically, if it loses its atom, if it loses its electron, then it becomes a cation and the other atom will become an anion. Similarly, if it gains both the electrons, then it will become an anion and the other atom will become a cation. So homolytic cleavage always give rise to free radical and heterolytic cleavage always gives rise to cation or anion. A chemical reaction to occur, there should be presence of attacking reagents. So the next thing what we'll be studying is the nature of attacking reagents. So the nature of attacking reagents, the first one will be electrophilic or electrophilic reagent, electrophilic reagent, or called an electrophile. What does this mean? Electrophilic reagent is the reagent which loves electrons, or it is electron deficient and it is in need of the electrons. So to write in a good way, these attacking reagents are electron taking or seeking or electron deficient. Again, these can be of two types. These are of two types. The electrophilic reagents are of two types. The first type being charged electrophiles, and for a electrophile to be, for an attacking reagent to be electrophile, if it is charged, it should always be positively charged so that it takes electrons. So these are charged electrophiles. The examples for this one, positively charged electrophiles are Cl plus, NO2 plus, R plus, R, CO plus. R being any alkyl or any of the hydrocarbons, carbon chain, any of the carbon chain. Now Na plus or K plus or any of these alkali metals cannot be, are not electrophiles. See, to avoid the confusion, those substances which gain stability after receiving electrons are attacking reagents or electrophilic, charged electrophilic attacking reagents, but not Na plus or K plus, as they are stable when they donate electrons. So those charged electrophiles attack that gain stability after receiving electrons. Category of electrophiles being neutral electrophiles. Those are namely BF3, AlCl3, BCl3, FeCl3. These are the main neutral electrophiles. Now coming to the nucleophilic attacking reagents. Nucleophilic attacking reagents. These are electron rich, electron repelling. They donate electrons to electron deficient reactants. So they can also be negatively charged or neutral. So the example for negatively charged nucleophilic attacking reagent is Cl minus, NH2 minus, Cn minus, OH minus, and those of neutral are NH3. Here there is a bond pair, it can be donated. H2O, here it is bond pair. ROH, RSH, etc. Here as well we can see that Cl minus, NH2 minus, these become stable when they donate an electron pair. So always the attacking reagents, if they always tend to the stability. If the negatively charged nucleophiles donate electrons, they will become stable, and electrophilic attacking reagents, if they take electrons, then they are stable, hence they are classified in this way. The next thing which we'll be speaking about is electronic displacements. Electronic displacements. Now what does this electronic displacement mean? Electronic displacement means the shift of the bond electrons towards an atom. If this is a molecule, whatever the valency of this atom may be, now this is the bond pair. The shift of electron pair towards one atom creates positive charge to the electron deficient and negative charge to electron rich atom. So in a molecule, the displacement of the electrons towards any other atom leaving behind charges is called the electronic displacement. Now this electronic displacements can be temporary or permanent. Now the temporary, in this video we'll be discussing only the temporary electronic displacement, and the only example of this temporary electronic displacement is electromeric effect. Electromeric effect, what is electromeric effect? It is the temporary pi bonded electrons completely shifted by the influence of the reagent. By influence of attacking reagent, when the only pi bonded electrons shifting is said to be electromeric effect. So the electromeric will be plus E effect or minus E effect. First we'll see about plus E effect. In this one, for an example, if this is a pi bonded carbon-carbon double bond structure and due to the attacking reagent, one carbon receives a positive charge, another receiving the attacking reagent is joined. This here we have received a positive charge, so it is a plus C effect. In the second type, minus C effect. If the attacking reagent is negatively charged, here it was positively charged, here it attacks the molecule, then one carbon will get a negative charge and to another carbon there will be attachment of this attacking reagent. So why this electromeric effect is temporary electronic displacement? As the charges created over here can interact with other molecules and the charges can be satisfied. This can be this molecule now further it can react with the nucleophilic reagent and get its charge satisfied. This can react with the electrophile and get its charge satisfied. So this is a temporary effect as the charges can further be satisfied.